So that's finding an angle. Okay, let's find a missing side. So for example, let's say we don't know what this is. We don't know what B is, but we do know that this is 26 degrees. So let's erase that. So we have here 26 degrees, but we are looking for B. We really want to know what B is. Okay, so okay. So whoa. So we're gonna see if finding B is just as complicated as finding the angle. Okay, so we're gonna erase this. Okay. Okay, so let's write the formula first. That's always your first step. Write the formula you're going to use. So we're looking for B. How, or could we have looked for C? Do we have enough information to look for C? No, we would need to know the angle here, but we can find the angle there, can't we? Then we could actually do something different. We could look for C. How would we find the angle? How would we find this angle? So we need to add up all of the angles, right? We need to add these up, and they should all equal 180. They should all equal 180 degrees. Okay, so we know that we know A already is 56. So 56. We know that B is 26 plus C plus C equals 180. Right. Right, this is the total. Okay, so let's add up 56 plus 26. What do we get when we do that?
Yet 2.
82. Okay, 82 plus C. 80 plus C equals 180. And then what we're going to do is subtract 82 from both sides. Okay, or we can just send across the 82, but we can also subtract 82 from both sides. All right, could do that. So you can do it either way. You can send across the 82 and it would become a minus, or you can do it this way. All right, so we have this 18, 17, 10, 8, and this would give me, what's 17 take away 8?
9.
9. Okay, so 98 degrees. Okay, so it shows you that this is not drawn to scale, is it? Because this looks like a acute angle. But actually, if we really want it to be accurate, we would have to draw this a lot differently. So that's to show you that the drawing is not drawn to scale. Okay, guys? This is obtuse. This is actually an obtuse angle right here. So a more accurate drawing would have been something like this, right? Something like that would have been more accurate for what's going on here for my B, C, and A. All right? So that's the cool part about math. I mean, I could draw this. I got my tools out. I drew it. I got a perfect triangle. But then when you apply math to it, then you realize, hey, this is not real. This is not realistic, right? It's not accurate. So that's something for you to check out. Okay, so now I can find C because I know this angle now. Okay, students, so let's look for C because looking for B would not be as interesting, okay? All right, so we're gonna extend this formula now. Which one are we gonna use, the top one or the bottom one? Which one will we use? We're gonna use the top one because the top one deals with looking for a side. And now we're gonna put, instead of B here, we're looking for C. You see how this formula works, guys? All right, so now, what is my A? My A is 15 over sine of 56. But look what I did. I have, yeah, I have the C on this side when I really want it on my left-hand side. So look, this is what I'm gonna do. Okay, we have 10 more minutes. So I have my 56 here. But because I want my C on this side, here's what I'm gonna do. Put my C over here. Haven't broken any rules because if A over sine of A is equal to C over sine C, then the same is true of me saying this is equal to that. So I haven't broken any rules by putting my C over here. And this is 98 degrees. Okay, guys, so check this out. You always want to make sure that your problem only has one unknown. You don't want to have two unknowns. If that's occurring, then you won't be able to solve it. Okay, so now it's time to get C by itself. How will I do that? This is the fun part. We actually get to draw a little bit. Well, how do I get C by itself? What do I have to do to both sides?
Times.
Times, I agree. But what will I be timesing both sides by? It has to be some way to get C by itself without breaking any rules. So I can't just come with my eraser and just, I can't do that because that would be illegal. So we can't do that. But what can we do? What is allowed? So we know that this is sine 98, sine of 98, and it's actually 1 over sine of 98. So to get rid of it, we need to multiply it by its reciprocal, the flip of that, right? So that's a principle you have to know. You have to know that you can always cancel out something by multiplying it by its reciprocal. So because sine of 98, the reciprocal of sine of 98 is 1 over sine of 98. And once you multiply a number by its reciprocal, it will always cancel out and turn into 1. So now I have my new problem, which looks like this. Well, whatever I do on one side, I have to do on the other side. Okay, so that's how you deal with that. That looks kind of weird. Okay, so this is C equals 15 sine of 98 sine of 98 over sine of 56. Okay, guys, now here's your task. You have to find sine of 98 to 3 decimal places, and we have to find sine of 56 to 3 decimal places. So let's do the sine of 98 first. What do we get? 3 decimal places.
990.
Yep.
999.
Yeah, 0.99. Okay. Over sine of 56.
We had 29.
Yes, 829. And now it's just a matter of multiplying everything together and dividing. So let's multiply 15 times 0.99. You get 14.85. And this is kilometers, because you see that 15 there? That 15 always had a km attached to it. And there was nothing that canceled it out. So it's still there. And then we have our 0.829. Okay, so 14.85 divided by 0.829 gives me 17.9. But you know that we're supposed to round this thing off, right? So what's my final answer, guys?
18.
18 kilometers. Don't forget the km. Guys, that's our lesson for today. Please take a screenshot if you can. Okay. All right. So were the steps clear? Were you able to follow along? Was there any questions? You understand the
Good,
process?
sir.
Yeah. So for the sine rule, you look for corresponding angles to sides. It has this kind of pattern to it. Check out the pattern. See? Corresponding. And then, so this is the pattern you get when you deal with the sine rule.